Welcome to the lecture on exposure, and also today I want to talk a little bit about depth of field because not only can one of the elements of the camera control exposure, but it can also control depth of field, which can give your photos a really cool look. The first thing I want to do is I want to just kind of review really briefly some things that we talked about with the eye working exactly like a camera. Now, here on the right, we have an illustration of an eye, something very similar to what you have in your notebook. And there are three different areas we want to talk about. Area A is the iris, and the iris of your eye changes the amount of light that enters your eye. We talked about this before. When there's a lot of light, your pupils or your iris are usually dilated. Are a little bit more closed to allow less light in. But if you flip the lights off and it's a little bit more darker, say in a living room or a bedroom, you'll notice after a couple more minutes, or a couple minutes after the lights being off, that details will actually start to come out. And that's because your pupil is starting to dilate or open, allowing more light to come in. With B, that's your lens. This is where you can change the shape to focus a little bit more on what you are trying to see. And again, we can use optics in the form of glasses or contact lenses to help us change that lens and change things, bring them back into focus if our eyesight is a little bit more poor. And then finally, C is the light sensitivity area where an image is formed. And again, this works just like the ISO or film speed. Remember when I said that you've been in a dark room and someone flips the light on all of a sudden and you go, oh my gosh, and you're reacted, you feel a little bit of pain, you're trying to close your eyes, and you just have to sit there and kind of squint a little bit because there's so much light coming into your eyes. That's because the light sensitive area is a little bit overloaded. Now let's take a look at the camera. Cameras are very similar to eyes again, as you can see over on the right side, because we have a light sensitive area in the back. That's the film or the digital sensor. We have our lenses. Instead of changing shape like our eyes do, they actually move closer or further away to the light sensor to allow a certain amount of light to come in. Our aperture in the lens controls the amount of light reaching the light sensor, which we can see there in the middle. That's an opening, again, in the actual lens itself. And then finally, the shutter, which is not on this diagram but would be just in front of the film, is a physical part of the camera that opens and closes to let the right amount of light fall on the light sensor and get a correctly exposed image. Now, really briefly, before we move forward, because we are going to talk about shutter speed, shutter is and shutter speed are two different definitions. Shutter is a physical part of the camera that, again, allows the right amount of light to fall on the light sensor to get a correctly exposed image. Shutter speed is the amount of time that something is open, or the shutter is open, and that's usually in a fraction of a second. I just wanted to clarify that because in the past, if I ask students to define what a shutter is, they actually end up defining shutter speed. Again, shutter is a physical part of the camera. Shutter speed is the amount of time the shutter is actually open. Here's a kind of cool cross section of what the inside of a digital camera looks like, and it's a little bit of a mess because there's so many things going on. But right about, and let me get the mouse here, right about this area right here, you see this little thin black strip of metal? That is the actual shutter. Again, it is light tight, so as light comes in through the lens like this, if the shutter is open, it will hit the sensor or the film, which is back over here in this area, but as long as that's closed, no light can actually come in to reach the sensor, therefore a picture is not actually being exposed at that time. Let's talk just really quick about lenses, and this is just going to be a refresher. So this particular slide, you don't have to write anything down on because we've already talked about lenses and you've already taken those notes. All right. We have two different types of lenses. We have removable, and those are usually for SLR cameras. And we also have fixed, and those are on point and shoots. You can see that in the illustration on the top. The camera on the left, the silver one, is a fixed lens. The one on the right is a removable lens. Then we have two different types of lenses that are removable. We have a prime lens, which is a fixed focal length. That means that if I buy a prime lens at 50 millimeters, it will only give me a length of 50 millimeters or a zoom of 50 millimeters. A zoom lens, which is the most common that's used, that actually has a variety of range of focal lengths. Those are the ones that I showed you in class where we can actually zoom in and out. So those are actually called zoom lenses. Go figure, right? All right. And finally, what does focal length mean? I wanted to give you a visual example of what focal length looks like. So we can see with the diagram on the right side that with a wide angle lens, that gives us a large field of view. Those are focal lengths under 50 millimeters. Then if we have a standard at 50 millimeters, remember the 50 millimeter rule, or the normal, we have the same perspective as the human eye. And then the telephoto lens with high magnification will give us for focal lengths over 50 millimeters. But if you look over on the right side, at 15 millimeters down at the bottom, we have a 110 degree view of field from left to right. But if we go to 50 millimeters, that narrows down to 46 degrees in our field of view. And then if we go all the way up to 600 millimeters up at the top, you'll notice that we only have a 4% field of view. You're going to see a little bit of an example of this later on in this presentation. First, let's talk about aperture. And aperture is there to change the amount of light that's coming through the lens and entering the camera. We describe aperture as an f-stop, and these have what we call an f number. Why it's an f number, I'm sorry, I don't know. Don't shoot the messenger, people. I just teach what I've been taught. So they're called f-stops. Aperture is the same thing. So down at the bottom, you'll see examples of aperture numbers like f2, f2.8, f5.6, f16, f22, etc. Notice on the right side, this is a lens that actually has, and this is an older lens for a 35 millimeter camera, that actually has a physical aperture inside it. So you'll notice down there at the bottom, you will see numbers 22, 16, 11, which it's set at right now, 8, 5.6, 4, 2.8, and 2. What that does is it will either open the aperture wide at 2 or it will close it very small at 22. The higher the number, and this is a little bit reversed, the higher the number, the smaller the aperture opening is. So if I set it to f22, that means I have a very, very small opening with my aperture, and less light is going to be able to come through that opening. On the flip side, if I set it to 2, then the aperture is going to be wide open, and a lot of light is going to be able to come in. So what you'll want to do with aperture is you'll want to gauge the amount of available light you have for the scene that you're shooting. If you're outside on a sunny day, you have a lot of light. So you probably want to make that opening smaller. So you'll have it set to maybe 16 to 22. If you're shooting around sunset and your light starts to become a little less than it would be at, say, noon or maybe even 2 in the afternoon, you will want to set that number smaller to maybe a 4 or a 2.8 to allow more light to come in. If you're shooting at night and all you have is the available light of candlelight or maybe a light on the side of a house or a barn or a bonfire, you're going to want that aperture wide open at a 2.8 or a 2 in order to allow that natural light to flow in through the lens. Now, most camera lenses, keep in mind that the wider the opening of the aperture, so for example, with this lens that you see right here, 2 is the widest it will go. The wider your aperture opening is on lenses, the more expensive that lens is. The 2 zoom lenses that we use in the journalism program actually has an f-stop of 2.8. That's the widest it will go, and those lenses were more expensive. Why those prices are set that way, I'm not 100% sure. I really wish I could tell you. But when you're shopping for lenses in the future and you want something with a more wider aperture, just keep in mind that those are going to be a little bit more expensive. So here is an example of what the apertures look like over on the right side. Smaller apertures, for example, f11, 16, or 22, only let a small amount of light go through. So you'll look up at the top, you'll see that little sun on the left side. Notice how much smaller the opening is. When it's set to 16, down at the bottom below it, or 22, the opening is much smaller. Very similar to the pupil of your eye. Large apertures, for example, f4, f5.6, and f8, let through a lot of light. So over on the right side, you'll see that our sun has a little bit of clouds over it, so we're going to open up our aperture a little bit more. So you'll notice that with the illustration down at the bottom with the numbers. So for a sunny day, you might need to use a small aperture to get the correct exposure. Now, letting the amount of light into a lens is only one of the functions of what an aperture does. So light is one part. The other part is called depth of field, which I'm going to get to in a second. All right. Keep in mind with aperture that each change of f-stop either halves or doubles the amount of light entering the camera. So, for example, the largest f-stop on a lens is called the maximum aperture. The maximum lens aperture is important because it indicates the largest amount of light that the lens will transmit. For example, in the previous slide, I had said that a 2.8 was the maximum aperture on the lenses that we have for the journalism program. On the flip side, a smaller maximum aperture f number, a larger aperture, a brighter lens is generally a little bit more expensive. All right. Now, I do apologize, guys. This is a new presentation. I got a little bit ahead of myself. Now I can talk about what's called depth of field. This is something that the aperture also controls along with the amount of light that comes in through the lens. Depth of field is the area of focus within your photo that can allow maybe your foreground and your background to be out of focus. So here's an example down at the bottom, and it's the best way to help to kind of describe it. If you're taking a photo of 3 butterflies, you have a butterfly close to you, you have a butterfly far away from you, and you have a butterfly in the middle. Notice that the butterfly closer to the camera and the butterfly further away from the camera are out of focus. But notice that the butterfly in the middle is in focus. The 2 lines that separate the 3 butterflies is your depth of field. The area in between the middle that says depth of field, where the center butterfly is, that area will be in focus. The area in your foreground and the area in your background will be out of focus. Depth of field can vary between shallow and deep. We have 2 different examples over here on the right side. We have a shallow depth of field up at the top, where you'll notice we've used the words depth of field with words beyond it. Notice that depth of field is in focus. The words down at the bottom and the words up at the top in the foreground and background respectively are out of focus. Notice down at the bottom we have a deep depth of field. Notice that everything in this desert background is in focus. The shrubbery in the front is in focus. The mountains in the background and the sky are in focus as well too. So with the varying ones, a large aperture number like a 2.8 or a 2 is going to give you a more shallow depth of field. Again, those are smaller f-stop numbers. That would be the example of the words on the top of the 2 photos. The smaller aperture or smaller aperture numbers is going to give you a deeper depth of field. So you want a large number. And I apologize, guys, let me backtrack. Large apertures will give you a shallow depth of field with small f numbers, and small apertures with the larger f numbers will give you deep depth of field. So I apologize, I was actually right on that. Ignore me sometimes, I just get kind of mixed up, especially with newer presentations, guys. I apologize for that. So I was right about the large numbers. A 2.8 is going to give you a shallow depth of field. With the larger numbers, like a 22 or maybe even a 32 on some lenses, that is going to give you a deep depth of field. And that would be an example of the photo on the right side. Again, if this was a little confusing, you can rewind and listen to it again, or you can also come up to me and you can ask me as well too, and I can just kind of clarify that. I do apologize, guys, there for the confusion with the voiceover there on that. Okay. Apart from using the aperture, the depth of field can also be varied and changed, for example, with the focal length, and that's varying your magnification. So here, and this is what I mean by degrees of our area of perspective based off of the lenses what we have. The varying focal lengths down at the bottom, we have a statue of a gentleman in Italy, and we have different focal lengths, and that, or the varying the magnification, changes our depth of field. So the photo on the left, this is a normal focal length, all right? So this is about 70 millimeters, and we have an f-stop of a 5.6. Notice that the statue's in focus. Also notice that everything behind him is in pretty good focus. It's a little bit out of focus because it's not as close as the statue, but that's more of a normal focal length. With a short telephoto lens, and what we've done is we've switched to a 135 millimeter lens in the one in the middle. Notice that the statue's in focus, but now our background is starting to become out of focus as well too. The other thing I want you to notice that we now have a shallower degree or a less degree in exactly what we can see in our field of view. The photo on the left side, we can see the building on the left with the windows and the building on the right with the windows with the chimney. With a short telephoto lens in the middle, our field of view has now narrowed. We no longer see the windows of the building on the left side. And then finally, the third photo, the one on the far right, is a telephoto lens. This is a 300 millimeter lens, and what it's done is it has dramatically reduced the depth of field to the point where the buildings in the background are reduced to a soft, abstract shape, and it's completely out of focus. But notice that the head of our statue is still completely in focus. What depth of field can do for a photo is it can make a background less distracting. Notice the photo on the left side, you have, sure, the statue, but notice how the statue gets a little bit lost in the colors of the statue and kind of that green-gray of the roof up behind his head. The photo in the middle is a little bit less distracting because we don't have the brighter colors, but notice the photo on the right. The only thing that you notice right away is the head of our statue. Everything in the background is out of focus, and that helps keep things a little bit more in focus for the photo person. Pardon the pun on that one right there. All right. Depth of field can also be changed by varying the focus. In this case, we have foreground, middle distance, and background focus. This is varying our focus distance. You'll notice that the photo in the left, if you look up at the very top of the spire, and this comes from the Vatican in Rome, if you look up at the right, and I'm just going to use my pointer here, right here, notice how these two kind of small parts up here, those might be chimneys, are a little bit out of focus, and that's a foreground focus. Here with a middle distance focus, they start to come a little bit more into focus, but with a background focus, they are completely in focus. Now, just to kind of reverse that, foreground focus, you notice that this column in the foreground is in focus, now a little bit out of focus, and in the background focus, it's being thrown completely out of focus. So depth of field can also be changed through that. You can be a little bit creative using your depth of field. You can help separate your subject from the background. You can give a feeling of space or distance to a scene if you want. And you can also highlight an area of the image that you want the person to actually view and look at a little bit more. But notice too, this photo down at the bottom with the hay, you notice how it gives a sense of strong distance because everything in the background is a little bit more out of focus as opposed to the hay bale in the foreground that is completely in focus. Gives a little bit more of a realistic look, especially for those of us who are a little bit more nearsighted and can't see things in the distance as clearly as we can in front of us as well too. You can also do this with flowers or other different photos just to give it a little bit more of a creative use. All right, let's talk about exposure in terms of shutter speed. Again, shutter is a physical part of the camera. The shutter speed is the amount of time the shutter will open in order to allow the light to hit the sensor. All right, and over on the right side, you will actually see an illustration. Up at the top, you notice how the mirror is down and it's not allowing the light to go through along with the shutter, and the shutter is actually right here. And then down here, if we open the shutter, now the light goes all the way through and it hits the sensor because the shutter is open and the mirror flips up. That's very similar to what I showed you guys with the SLR camera that didn't have the lens on it. When I hit the shutter, you could actually see the mirror pop up, but it's really hard to kind of see the shutter because it does move so fast, okay? In digital and compact cameras, the shutter may be electronic, which is where the sensor is only receptive to light for that shutter period, okay? So again, shutter speed is the amount of time that the shutter is open, and this allows the film or digital sensor to receive light for an exposure for that certain amount of time. The effect on a shutter speed can kind of vary, keeping a consistent aperture. So if we keep our aperture the same, you'll notice we have different exposures at different settings. We have 1.3 seconds for a shutter on the left side, and then we have 15 seconds of shutter speed over on the right side. When the image starts to become too dark over on the left with a short exposure, that means that the photo is underexposed. It's too dark, not enough light has come through the camera. A correct exposure around 4 seconds in the middle of this strip means that we had just enough light coming through the camera. And then finally, a photo that's overexposed or too bright, the example would be with the 15-second one over there, can cause some of our photos to be washed out, or a lot of our detail can also get lost as well too. Shutter speed not only allows light to come in through a certain time, it will actually help with what's called freeze motion and blur motion. A fast shutter speed with the photo of the waves up at the top can create a short exposure, and that is required to help with freeze motion. The photo on the right side was taken with a shutter speed of 1/1000th of a second, or 1/1000th of a second. And that really helps to stop the droplets of water and give detail to the waves. But notice that the photo down at the bottom, a slow shutter speed in reverse is going to, or it's a long exposure, is going to give a blur motion for some more interesting effects. The photo down at the bottom, you notice how the water is a little bit more blurry. This gives a sense of actual motion. This was actually 1/15th of a second for the shutter speed. Now, this is a typical scale for a shutter speed, and notice that if we start from the bottom and work our way up from 2 seconds, which is the slowest, up to 1/8000th of a second, which is the fastest, notice how the time doubles every time we go up. So we have 2, 1, 1/2, 1/4, 1/8, etc., 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 going on up the scale. The speed doubles every time that we move up the scale. What I do want you to do is go ahead and take a second. You can hit pause if you need to, and go ahead and get this scale down in your notes. You can kind of do it off on the side if you want to, if you're worried about taking up room. Again, the fastest shutter speed is 8,000th for this one. The slowest is 2 seconds. You can also create some interesting effects with longer exposures, 30 seconds or more. These can be required in low light area, but they can also produce some nice effects. All right, for example, look at the scene in this photograph. Notice how it looks foggy? Well, there wasn't any fog in this photograph when it was taken up in Ireland or the UK. And by doing a 30-second exposure, as the waves were lapping over the rocks there, it just gave a blurred motion, and in the end, it just looks like a small blanket of fog is actually sitting over the water, when in reality, that wasn't the case. So very long exposures can give you some really fun effects. If you get a chance today or at some point, go into Google and look at long exposure photographs and just hit the images and see what kind of fun images you might actually see on there. Now, ISO or film speed, this is the sensitivity of the digital sensor to light. Remember when we were talking about the eye and I said you flip the lights on and all of a sudden you're like, oh my God. That is the sensitivity of light, and it's measured by ISO, or the International Standards Organization. That's why it's called ISO. Hey, you learn something new every day. Also notice that the amount of light, or the amount of light sensitivity, will double as you kind of move down the list over on the right side. So here are the standard film speeds, or the ISO numbers, over on the right side, starting with a 100 ISO. That's where the film or the digital camera sensor is least sensitive to light, all the way up to 3200 ISO, which means that it's most sensitive. So what does this mean? Well, again, you have to measure the amount of light that you have in your scene. The more light you have, the lower your ISO number needs to be. If you're shooting on a very bright sunny day in the middle of the afternoon, you'll want to shoot at a 100 ISO, especially if you're taking photos out in the snow and the sun's out. Oh my gosh, that is some blinding light. You definitely want your ISO to be the smallest number you can possibly get it to. With the 3200, if you're shooting indoors and you're shooting at a concert where you have low light or you don't have a lot of light, you'll want to set your ISO higher to make it a little bit more sensitive to the smaller amount of lights that is coming in through the camera. So again, just like the shutter speed, go ahead and get these numbers down in your notebook as well too. 100, 200, 400, 800, 1600, and 3200 as well. This is an example, or this is what a digital sensor chip actually looks like in a digital camera. I didn't want to actually break one open and show it to you, so we just kind of found this one. All right, so that's it for the notes. Let's go ahead and kind of test what you see here, all right? Take a look at this photo and tell me, is it underexposed or overexposed? The answer is it's overexposed. Notice how with the white and all the snow, you lose a lot of detail in the background with the white, all right? If it was underexposed, it would be much, much, much darker, all right? Which one of these three is the largest aperture, which means the number would be smaller? Remember, aperture affects a shallow depth of field. So which aperture is the largest? It's the photo in the middle. That is the actual largest aperture. And here's why. Look at the lamp in the background. Notice that it is the most blurry in the middle. What we have done is we have an aperture opening of a 2.8, and that makes our it makes our depth of field more shallow. So the head up in the front, or the statue head up in the front, is where our depth of field is at, along with his companion off to the right. So everything in the background is going to be out of focus because it is out of our depth of field. Only those two faces in the front are actually in our depth of field. Is this photo under or overexposed? The answer is it's underexposed. Look in the shadows. You notice how the shadows are extremely dark and there's no detail in them at all. That means there wasn't enough light when we took this photo. So again, we might have to change shutter speed, we might have to change our aperture, or we might have to change the sensitivity of our ISO as well too. This is the last one. Is this a small or a large aperture opening? Since you figured the last one was actually a large aperture opening, you're probably going to say that this is a small aperture opening, and you would be correct. With a smaller aperture of opening, we have a wider depth of field. Notice how everything in this photograph is in focus. So we give ourselves a wider or larger depth of field area where we're actually able to put everything into focus. All right, guys, that does it. That's the lecture over exposure and depth of field. As always, if you have any questions, please don't hesitate to ask, and good luck with your camera settings.